Hello, so in this lab we will be creating route 53 record Alias to route traffic to an application load balancer with the help of Terraform. So first we will be seeing why do we need route 53 record Alias and why it is used to route traffic to an application load balancer. So if we look into our simple DNS, in simple DNS query we will mention the domain name and DNS server reply us with an IP address and we get access to the web server. Similar type of function is of the route 53. We will want to get some access to a web page, and route 53 DNS will give us the IP corresponding to that, and we will get access to that EC2 instance or that web page with the help of route 53 IP provided to that. But what is the difference? So Amazon route 53 is highly available. First, it will be set up in the different region and scalable, means we can scale this into the geographical area, and it is cloud domain name system DNS service, that is it is used to host the website for static purposes. Now this route 53 DNS can be used to for the cloud domain name system, that is the application hosted on the cloud servers, not on the simple DNS servers, and then it is extremely reliable and cost effective and help to route traffic to the web application. It is also easy to map load balancer EC2 instances S3 buckets, which we will be seeing in later part also, then it will get clear. So also it is also offer traffic flow for easy configuration, means if there is a failover at one place, it will reroute the traffic to the other place, which we can see here. So in three words, if we have to summarize what is route 53, it provide availability, high reliability, and integrate easily. Now we will be seeing what is meant by this integrate easily, that the word is coming again and again, that is integrate easy. So and it contain Alias record and Cname record. In this lab we will be using Alias record lab. So it will redirect query to the selected AWS resources, means in our AWS console there are various things present: Amazon S3 buckets, Cloudflare distribution, and other things which are EC2 instances. So we can route our traffic, means we can redirect our queries, that is DNS queries, to these instances or resources present in the AWS with the help of route 53, which is not provided by the DNS type of service. It will also only route traffic to some web page, but here we can redirect our queries to the Amazon S3 buckets, Cloudflare distribution, and Amazon EC2 instances. We can also see here we can means change the subdomain of our web application, that is in an Amazon S3 bucket there is ACME application acme.example.com. We can also create alias record for this, that is zenithexample.com, that is we have changed the subdomain. And what is the difference with the cname record? Cname record can also redirect query to any DNS record, but it will also can change the top level domain name, that is there is a web application domain name which is acmexample.com, and we have to host it, redirect query to the zenithexample.com. We can also do that acmexample.org, that is we have changed the top level domain name from the .com to the .org, which is not provided by the alias record, but it will cost extra charges when we have to use this for the AWS, depending on the queries which we are performing. So we get idea about what is meant by integrate easily here, that route 53 providers, which is availability, integrate easy, and reliability, which is traffic flow whenever a failover take place, and it is easy to map load balancer EC2 instances, that is we can request query and redirect queries to various instances of an Amazon S3. So in we can also see from example here that we have mentioned a domain name, then DNS root server will give us the top level domain name for that web server, and from top level domain name we get access to the route 53 name server, and from route 53 we will get IP corresponding to the web page which we will be requesting. So but in this lab we will be also be putting an application load balancer here, so that the IP corresponding to this will distribute this traffic into the web application hosted in two regions, Apache server 1 and Apache server 2. So if we reload the application various time, first we will get to Apache server 1, then sometime goes to Apache server 2, that is we are putting application load balancer, which we will see in this lab also. So this is the lab scenario. These are already available for us, which is VPC created, already configured for us, VPC route table, internet gateway, public subnet 1, and our web application is hosted on these instances. And on the top of that we will be putting application load balancer, and a target group configured with this load balancer to distribute our traffic in the two region, which is on one region Apache server 1, and on two region second region Apache server 2. And we have also configured ACM certificate for the security purposes. So it issues certificate and attach it to the port 443 of the application load balancer. This port 443 is configured for the HTTPS packets. Means it will be this application load balancer will be getting packets on port 80, HTTP packets on port 80, and then forward that HTTP packets on port 443, which is configured for HTTPS, where security checks can be performed by the ACM certificate, as HTTPS requires security certificates. And then on the top of it we have put the route 53 domain, so for the high reliability, high availability, and for the integrate easily purpose, that is we can, it is easy to map and easy to map load balancer, easy to instances, and S3 buckets in this scenario, which we have seen also. Now we get some idea what we'll be doing in this lab. That is, we will log in into the Terraform controller node and copying our Terraform code, which is containing, which we can see here. First, we'll be putting the IDs of the already configured VPC security group subnets and Apache instances, which is this we have copied for the VPC master security group subnets and Apache server hosted on two regions where our web application get hosted, and our server can recognize it. Then we have fetch pre-configured publicly accessible DNS domain name and copy that DNS domain name and put in variable.tf. That is, this is our domain name cmcloud.info, and copy that and put in the DNS variable.tf file, which we will be deploying our Terraform code. So that this is pre-configured publicly accessible DNS domain name provided to us. We can also change the subdomain name. That is, for here we are using my site, so our final URL will be my site cmcloud1602.info, which we will be seeing also later. So this is our final domain name through which we will be getting access to the website. And also we can also look into the application load balancer, which contain the definition for our application load balancer and ACM certificate generated. So we'll be getting all the traffic on port 8080, which is HTTP, and which will redirect, we can see here, redirect all the traffic to the port 443, which is configured for the HTTPS. And here we can see that listener for the HTTPS which is listening on the port 443. And here it is, we have also attached the ACM certificate for the verification of the as HTTPS require verification of the certificate. And there we have forward all the traffic to the target group mentioned, which perform health checks and other things. And there is attachment for our web application on Apache server 1 and Apache server 2. So our target group attachment will distribute traffic between these two Apache server, that is sometime on Apache server 1 and sometime on Apache server 2. So whenever I click on my domain name, I will get sometime on region 1 and sometime on region 2. So we have get info that what we will be doing. First we have change the domain, set the domain name, which is pre-configured domain name, which is already configured for us, and can change the subdomain from here and get look at the automatic application load balancer and ACM certificate generated. Now this is what we are doing in this lab, that is cloning the GitHub repository and cloning the GitHub repository for Terraform code and get public hosted root for this and deploy our Terraform code and apply the changes. So if we look into the website and reload this, first it is hosted on web server 2, and if we reload it, sometimes it is getting hosted on the web server 1. So our our means our objective for this lab has been clear. That is, we can also see the URL of this website, which is my site cmcloud1804.info, which I have mentioned here also. That here we have mentioned the domain name for the website through which we will be accessing the site, and we can change the subdomain name from here. But this is already pre-configured and publicly accessible domain name provided to us, so we cannot change this. But we can change the subdomain, as we have looked in the Alias record that we have mentioned in the previous example, that comparison of Alias record, we can get access to the Amazon S3 bucket and cloud for distribution in the Amazon web service. So our objective for this lab is achieved. That is, we can see here that we have put the application load balancer, which is redirecting traffic to the two regions, two Apache regions, and also issue certificate to the port 443, which we have seen here. Issue is certificate to the port 443. First, it is getting traffic on port 80, which is forwarding all traffic to the port 443, and it will forward all traffic to the target group, which will distribute the traffic into these two Apache server. So and we have put the route 53 on top of it, so that it is highly reliable, highly available, and we can integrate it easily, so that get different instances, that is easy to instance S3 bucket and get access to that website with the help of route 53 domain. So our objective for this lab has been completed, and we also get to know that this is similar to this one example, but there is one difference. We have put the application load balancer here, so that it can distribute traffic between the two regions. So that's all for this lab, and thank you.